Good day to Dr. Sri Devi. We are Group 8 and our paper is Geranium, a Multimodal Retrieval of Genomics Data Visualizations, co-authored by 6 experts at the Harvard Medical School in Boston, Massachusetts. I think I move to next slide now. Okay, so our paper falls under the IR research area of multimedia and multimodal information retrieval, specifically retrieving domain-specific visualizations using image, text, and grammar-based queries. The core problem is simple. Here, there is no dedicated retrieval system for genomics visualizations. Genomic researchers today face a major bottleneck when creating visualizations. They have to manually search online for examples, often rebuild them from scratch, and struggle with multi-scale data that looks completely different from depending on the zoom level. And this matters not just for saving the researchers' time, but for enabling productability in publications, lowering barriers for non-expert biologists, and supporting AI-powered precision medicine. The gap was validated by interviews with 20 genomic experts. Okay, moving on.
So the objective of this paper is to first achieve efficient visualization retrieval by introducing Geranium system, and then streamlining visualization construction by providing researchers with reusable templates or scaffolds that they can adapt with their own data. Next. So how it improves existing system is through multimodal search capacity by allow for more flexible query. Then it also integrates 3 distinct embedding methods, which is context-free grammar, biomedical vision language models, and then fine-tuned large language models. And then lastly, it also support for domain-specific features. Next. So what's the existing problem right now is the bottleneck in the genomics workflow. While effective visualization is critical for integrating complex biological data, finding relevant and modifiable ensembles is time-consuming and inefficient. So the main contribution of this paper is introduce the Geranium system, and then it supports multimodal representation, and lastly, prove that context-free grammar CFG approach is highly effective with low computational cost. Next.
So moving to the methodology, Geranium uses a multimodal retrieval approach. The goal is to create an undefined search space where the system understands 3 distinct input, natural language text, visual image, and the underlying Gaussian code. Next slide. The engine behind this is a combination of 3 specialized models. First, a grammar-based model. This uses constructive learning to understand the structural DNA of the visualization code. Second, a biomedical vision language model. This allows the system to see a chart and recognize complex patterns like a Manhattan plot by linking pixels to medical terms. So third, a fine-tuned LLM. This handles our human query, ensuring the system understands biological context and technical symptoms. By merging these 3 branches, Geranium don't just find a picture, it reveals a financial scaffold, a code template that researchers can immediately reuse for their own data. Next.
So next, I will explain on the process and also the data used in the system. So the dataset contains about 3,200 genomics visualizations across 50 categories. So each of these visualizations is stored as multimodal triplet, which is in the form of image, text, description, and also specification in Gaussian format. So this allows the system to represent the same visualization in different forms. So in terms of the workflow, as you can see here, it is the overall flow of the process. So next, we'll get into the details. First, the user can input a query using text, image, or description. And then the system will convert the input into an embedding, which is a vector representations. It is then compared this embedding with the stored dataset using similarity measures and ranks the results. So the most relevant visualizations are returned to the user.
So significant findings. So the results show that Geranium is improved retrievals, accuracy, and combining image, text, and grammar base. So it's better than single modality system, and the CFG methods achieve high effectiveness with low computational cost. Next. Based on table 1, we can see that the system achieve high top K accuracy as is often 70 to 80%. It also reliably work and as different inputs such as text, image, and codes. And lastly, this shows that the system is consistent and effective regardless of how the user searches. Next. So for interpretation for graph, so the graph shows that as we increase the number of results, accuracy also improve, and also it close to 90%. and all the methods remain stable, and like model biomed clip is perform the best because they understand the biological data. Next. In conclusion, so Geranium provide a flexible retrieval system as it proves that CFG approach is highly accurate as the match code and computationally heavy. So it can replace manual chat building with a search and edit process. So that's all from us. Thank you.